Yeah. It lowers and then that's so like how much
I was trying to make it perfect.
That was not hard to understand.
So I was like, I missed it. I forgot.
So on the normal hybrid, it's 26. Yeah. Okay. So
My name
the new one.
I can be shy.
They're starting to get really popular.
Okay, that's
Everybody ready? All right. So recall that your exam will be on Friday. So come to class if you would like to take your exam here or do it from home. It'll be the same as last time, 24 hours long. You may submit as many times as you like, and it will be based off of the questions that are at the bottom of all of the different lectures. And again, not all of the questions make sense that are in there, and not all of the answers that are given to the questions are correct. So use your judgment and your internet researching to answer anything that you don't remember about. So today we're going to talk about setting up a web server. So who has a Windows computer of any kind? Who does not have a Windows computer of any kind? All right, this won't work for you guys. So this is how to turn your computer into a web server if it is a Windows computer. So why will you need to do this? You guys are all going to get your own VMs or virtual machines next week, which is going to be your own server. So it's like you use remote desktop to get to it. So you just click on the start menu, type remote, and you get remote desktop, remote desktop, and then it's going to ask you where you want to connect to. So yours is going to be GEOG 478- a number, like first the A in the class is going to get 01, and the Z is going to get something else, dot something dot geos.tamu.edu. So you will just remote into your computer, and it opens up a screen on your screen that looks exactly like a Windows desktop. So it's another computer that you will be controlling from your computer. So it works exactly the same like Windows does. It's just going to be a Windows server instead of whatever version of Windows that you have. So inside of there, you will go through these steps to set up IIS, which is Internet Information Services or server, which is the Windows web server, which is included with every version of Windows. So you just have to turn it on and configure it properly. Why are we going to be doing that? So you can be given the fun of writing the front end and the back end of a web page. So that's what we're going to talk about today, is the setup process and what the different two sides of the page are. So IIS, as was mentioned, is included with every version of Windows. It's just a checkbox that you have never checked before to turn it on. So on Windows 10, it's going to look like this. You have to find the Add Features part of the control panel of Windows. So easiest way to do that is just type Features in here, Settings, Apps, and Features. In this little search box, it's part of the control panel, so you can get to it from the control panel if you wished. Oh. So it would be in here, turn things on and off. So since I'm not an administrator on this computer, you can't see it. But on my laptop, you might be able to see if you're the owner of the computer, meaning you're the administrator of the computer. It's going to bring up this little square gray box, which is going to have every possible thing which could be turned on for Windows. So it's eventually going to look like that. All right, so there's a whole bunch of things that you have never heard of or used before that are included with Windows. So the ones that we need to turn on are .NET Framework 3.5, .NET Framework 4.7, and IIS, Internet Information Services. So once you do that, you get access to a different type of program, which is called the IIS Manager, I guess. And to find that, you would then type in here. Once it's installed, or once you check those boxes, it's going to take a couple minutes, and you're probably going to have to do a Windows update afterwards. So you would type IIS, and it would pop up. So IIS, Internet Information Services Manager, which is then going to show you this little console right here. This I need to get rid of, right? So this is what your web server looks like for you, like the manager of the web server. On the left-hand side would be all of the lists of websites that this web server is serving up pages for. So on a desktop computer, you can only have one site. So this one is called default website. But on a server, you can have hundreds or thousands of websites on this one computer. So this is how hosting companies operate. So there's like gazillions of different web hosting companies out there that will host your website for you. And they're either going to be doing it on Apache servers or IIS servers. So on their server, which you will have the same thing because you're going to get a Windows server, you can just add more websites in there. So one server can host as many websites as you want it to until it starts using up all the memory and all the CPU. So the Windows web server is actually pretty lightweight. So when it's getting tons of requests, like if your page is very popular and lots of people are coming to your website, it actually doesn't take that much CPU or memory to process the request for a page. So when I was working at a hosting company, we were using just like regular desktop computers as servers, and we would have 250 websites. This is in like 2012 on just an old shitty computer. So you can host as many websites as you like. So if you have a static IP at home from your cable modem, you probably don't. You can purchase that if you wished. You could run your own hosting company from your house if you wanted to. You just have to open the firewall, which we'll see how to do in a couple steps. Then you set up a web server, and it just sits there listening for requests coming in. And remember that one IP address can have, well, each computer has to have at least one IP address, but you can configure multiple websites to run on the same IP address. So you might be wondering, there's a gazillion internet sites out there. How are we not running out of IP addresses if each one has to have its own IP address? That's how, is that multiple websites can be all on the same IP address. So that's how we can save IP addresses. So inside of this little control panel, you got websites on the left, and then whatever you're clicking on. So if you're clicking on a server or a specific site, you'll see different stuff inside of the window to the right. Most of these you never need to mess with for any reason because the default settings are just fine. But if you needed to do something special, this would be the place where you come in and configure a web server specially. So also in here you can stop and start and restart the whole server or just specific websites because websites do crash from time to time. So you might have to stop it, start it again, or just hit restart. So it's contextual. So if you've had the pleasure of working with ArcGIS Pro yet, you see different menus depending on what you're doing. So this is the same based on what you're selected on the left-hand side. You're going to see different options here on the right-hand side. So on your desktop, since you can only have one website in a non-server version of IIS, everything falls under the default website, which is just localhost is the name of your computer. So if you type in http://localhost, it would bring you to whatever the default website is. And inside of websites, you can make what are called applications. So these would just be folders located somewhere on your computer. And you would right-click on the website, say Add Application, and then you can add as many separate websites as you like underneath the main one. So if you're working on a server, you wouldn't need to do that because you can have as many websites as you would like. But on desktop version of Windows, you can only have one website, but you can have sub-sites underneath it. So the ones that are shown here are agimap.tamu.edu, alumni.geog.tamu.edu, and routing.agimap.tamu.edu. So to access those ones, you would go to http://localhost/ whatever the name of the site is. Cool. So here's the example of doing that. All right, so you right-click, add application, and you're going to set a couple different things in here. The alias is what is the name of this thing. So if you want it to be agimap.tamu.edu, you would write agimap.tamu.edu in there, and then to access it, you go localhost/agimap.tamu.edu. You don't actually have to name it like a site. You don't have to name it something.com or something.edu. It doesn't care. We just do it that way to keep everything organized. But it could be default website/website1 with no .com, no .edu, or anything like that. So that's what goes in alias. Physical path is the folder where the HTML files for that website live. So they can be anywhere on your computer, and you just have to say where that folder is. And the application pool is which version of .NET is going to be used for the site. And generally, just leave it at default unless you have a very specific need to use a super specific version of .NET. Cool. So once you have done that, you'll be able to go to http://localhost/ whatever you named that website, and the website will run. All right, so IIS supports HTML, JavaScript, and CSS, obviously, but it also has its own programming language for Windows, which is called C#, which we'll go through in a second. But this turns your desktop or your laptop or whatever you're using into a full web server. So no one will be able to see stuff on your computer unless you give them the link or they know your IP address. All right, so you might be worrying, all right, so if I set up a web server on my computer, am I going to get hacked immediately? Generally not. At home, you're going to be behind your firewall, which means no traffic from the internet can come into your house unless you open it. On campus, it's potential that potentially some student is just randomly going to IP addresses / whatever to see if there are web servers listening. And they would be able to see that you had a server running that was answering questions for web pages. But the likelihood that you will get hacked is pretty slim. But if you don't need to be running a web server on your computer, you should not turn it on. All right, for this class, you're going to turn it on, and then after the class, you can just turn it off if you don't want it to be on anymore. All right, so the application pools, there's a bunch of different kinds. So have you guys ever had to install .NET for anything? Maybe, maybe not. Like Windows updates always are going to be updating the .NET framework on your computer. So the original one started at .NET 2.0, then there's 4.5, then there's 4.6 now, and there's like the classic .NET application pool. So you can pick, you can have multiple of these. Like you might have old code that somebody gave you from the 2000s that just hasn't been upgraded to work with a newer version of .NET. That's why you would need to use one of these older ones if you don't feel like going through and rewriting their whole application to make it work with whatever the latest version is. So that's why these are here to support basically old code, and you will just do default for the most part. All right. Then a very important part of getting your web server to work is opening the port on your computer in the firewall that HTTP traffic goes over. All right, so by default, your computer doesn't have any ports open other than standard Windows 1. So you're now installing a service that runs on your computer that is expecting internet traffic to come in on a specific port. Do you guys remember what the specific port for internet stuff is? I'm glad you're learning a lot in this class. Yes, 80 is the correct one. You remember the SSL port? 443. So if you want your computer to be able to hear requests for web pages, you have to open your firewall on whatever ports you want to be open. So if you're going to be doing non-SSL web pages, you need 80 open. If you're going to be also be doing SSL web pages, then you also need 443 open. So have you guys ever had to mess around in the firewall of your computer before? Some yeses. It's generally for when you're trying to run servers or something on your computer. You have to poke holes in the firewall to allow traffic to come in on that specific port. So when you open it up, you're going to see tons and tons of stuff in here already, which is just by default Windows installation. And you can also see the inbound and outbound rules because you have a firewall that goes in both directions. So you are going to have traffic coming to you, so you need to add an inbound rule, so stuff coming into your computer to open up that particular port. All right, so I believe there is a picture of doing that. Nope. Any guesses from this picture how you would add a new rule? You would click on the new rule button, all right, and it's going to ask you what port do you want and what do you want to name it. So you're going to open up port 80, and then you're going to name it anything you like. If you name it IIS, that's helpful for you to find it later. So if you have other types of servers running on your computer, like if you have some kind of game server or something like that, then you would have to do the exact same thing on whichever port is necessary for that. Other common things you would run into in business would be the need to open up the port for SQL Server or MySQL or Oracle or something like that, right? Because those are database servers that are expecting traffic as well. So you would just have to type into Google port SQL Server, and it will tell you the exact port that you need to open up. So if you have your computer configured properly, you now have yourself your very own web server. So what would you do with your web server? You would start writing either just plain HTML, JavaScript, and CSS if you don't need any backend stuff, or you would start writing C# with ASPX if you needed to do backend stuff. So do you guys have any idea what backend would be versus front end? What do you think?
Would be the things that the user can see.
Yep, it'd be the things that the user doesn't see, right? So a very common thing that you would need to do on a web page is go ask a database for a list of products and then show products on web page. All right, so in HTML, JavaScript, and CSS, there's no way that you can connect to a database. The connection to the database is done from the web server to the database, right? And you don't want any regular old user of your website to be able to right-click view source and see the username and password to get into your SQL server where you store all of your products and all your company information. So that's why we call it backend, because it's behind what the user can see. So the most common case is getting data from a database to present to a user. All right, so but there's also other ones, like you might have some login logic, right, where the user has to enter a password. You go take the password they entered, compare it against what's in the database. If they match, then you allow them to be logged in. So it's talking to the database. And then the server keeps track of the fact that this user is now logged in. So you don't have to click login on every single page that you go to. So that's called session state. When you are interacting with a website, like doing stuff, it creates a session just for you and your computer and your browser that maintains some of the state about your particular session. So is this user logged in? What is their username? What is their user ID? What is their email? All that kind of stuff. So to program that kind of logic of information that you need to keep track of related to a user that you don't want to just write in HTML into the page, you need to be programming the web server. So the language on Windows that is most common for doing backend type programming is called C#. And it looks like this. So it's got two parts of the page. So this one right here would be the equivalent of the HTML file, right? So it looks HTML-like, right? It's got tags in it that open and close. It's got meta tags, which is just regular HTML. So in the ASPX page is where you would write your HTML, JavaScript, or CSS. And then the .cs file or C# file looks more programming-like. All right, so if you're familiar with Java, C# and Java are nearly identical programming languages. So if you're able to program in Java, then you will be able to program in C#, no problem. So it has like regular Java syntax, or like regular Java syntax, I guess. This is C# syntax, but you can say we can define classes. We can have functions that take parameters. We can inherit from other pages. That's what this little colon at the end means. That this page, logout _ default, extends the abstract user manageable bash service manageable stateful page. Yes, I came up with that word. So with a combination of ASPX, which is handling the front end of what the user actually sees, and the C# pages behind, the two work together to allow stuff to happen on the server, right? So a common thing would be if you have a button, like button that somebody's supposed to push, and when they push it, the server's supposed to do something. You make what's called an ASP button, and then this little on click is going to call whatever that function name is in the C# file. Right, so this is the ASPX file, looks HTML-ish, and it's saying when the user clicks on the button on the web page, go into the code behind and run whatever that function is. So let's see if we have button submit click here. We do. So that button press is going to transfer into the programming code, the code behind, and it's going to do whatever it says to do in here. All right, so this one should log out the session, and redirect the user back to the home page. All right, so this is some application logic that we, the programmers of this website, came up with because we figured that was a good way that we should do it. And this is not anything that the user should ever know about. They shouldn't know how the internals of your website work. All right, so none of this C# code will ever be shown to the actual web visitor. They don't see any of this stuff that happens in the background. They only see what is in the ASPX file. And the ASPX file gets turned into regular HTML by the web server. So you can write plain old HTML in here if you wish. It doesn't have to have anything in the code behind. It just has to have a code behind file. But that wouldn't make a lot of sense because that's overkill. You should just have an HTML file if you only need an HTML file. So this is the Windows way of doing it. The Apache way would be you have Apache MySQL as the database, so Apache as the web server, MySQL as the database, PHP as the programming language. So PHP is a little bit different than ASPX plus C# in that there's only one file that you write, and it's .php. Right? So you don't have a front page or a code behind page. You just have one page where you can embed logic inside of what appears to be a regular old HTML page. So the Windows way of doing it is a little bit more complicated, and I have no idea how or why it got to be this way. The PHP way is simpler because you only have one file that you ever need to mess with. And you do your connection strings to the database directly in the PHP file. You write your SQL query to pull your products from your database. Gives you back a list, and there's for loops that you loop through the list, and you just append rows to a table, for example. There are alternatives as well. So you may remember days of servlets or Java server pages. No? Never? Have you ever had your computer logged into Howdy, left for a few hours, came back, refreshed the screen, and you get like a weird looking error page? It says shibboleth error, like not logged in, not authorized. That is the output of a JSP page. So you can run Java underneath a website, right? So we're looking at examples of using C# underneath a website. We just talked about PHP as underneath a website, or you can write just plain old Java and have that underneath your website too. So you can write it in JSP, which is a Java servlet page, which is very similar to PHP in that everything is just in one page. It's just different syntax. Or you can write an actual servlet, which would be just regular old Java code that gets converted by the server into a web page. So there's lots of different options for web servers and web backend programming. And the one that you're going to use is whatever your company uses. So whatever they made their first website in is what they stuck with, probably, because it's very expensive and time consuming to redo all of your websites for whatever latest, greatest technology comes out. So you are definitely not going to be an expert in C# programming at the end of this class, but you will at least have made one page that says hello world and potentially connected to a database in C# to get data out and send it back to the user. So other options are Cold Fusion, you might have heard of that one, is another programming language. Ruby on Rails is another programming language. Node.js is another programming language. Or sorry, those are all web server systems plus languages. So there's at least 5 or 6 commonly used ones. The most popular would either be PHP or C#. So nobody really does Java for their web pages anymore because Java is annoying. Ruby is pretty popular, I guess, still. Cold Fusion is not as popular as it once was. But they all do the same thing. They allow you to have code and logic that you write to support whatever application you're building that does all the behind-the-scenes work of your website, and then they only present to the user just the HTML, JavaScript, and CSS. So in WebGIS, let's see, if you're using Arc server, you might have some instances where you have to write some C# code of your very own. So working in C# is useful because Windows programming language, so you can access anything that you can do on a Windows computer. Right? You can contact Active Directory and see if users have user accounts. You can make administrative pages where you disable user accounts from a web page. You can monitor the CPU and all the performance metrics of your computer through a web page. So programming in C# gives you access to all of the Windows stuff that you might ever need for anything. And Esri and most other companies have built versions of their system for Windows. So in ArcGIS, it's called ArcGIS Runtime, which allows you to call from C# code any function of ArcGIS. So you can do .buffer, .clip, whatever. So you can do it in Python if you just want to write a script, but scripts are hard to like make into web pages. So if you want a web page to manage some GIS stuff, doing it in C# is very easy because Esri has provided a whole their whole system as .NET things that you can just call. So since most businesses use Microsoft, most companies are programming in C# if they need to be interacting with the Windows machine or servers or anything like that. You can do it in Java more difficultly. PHP, you cannot access things about the computer. So it's a protection that they built in that you can't do. Like in PHP, in C# you can get all of the user accounts on a computer if you wanted to. In PHP, you can't do that because it's separated from the operating system. So C# is a lot more powerful in the things you can do, but it's also super dangerous. You can expose a whole bunch of information about your network or your users and things like that if you don't know what you're doing. So that is IIS in a nutshell. Basically, any Windows computer can be turned into a web server. The web server can host any number of websites that you wish. You have to make sure your firewall is open. And if you needed some backend stuff on Windows, C# is the language to do it with. So you guys, next week will be, there's no lab next week because it's not a religious holiday, right? Or is that the following week? Next week? All right. It's a reading day. It's definitely not Good Friday. Definitely not. So you will go through all of these steps on your server the following week. So at that point, you will have the equivalent of your own personal hosting company, which means that you can start serving up porn. You can start running BitTorrent stuff. Please don't. But you will be the owner and lord of this computer. So there's nothing stopping you from doing it other than you stopping you from doing it. But there won't be any difference between the machine that you get and what runs the internet. It's the A&M firewall, the main A&M firewall, is not going to be open for your computer, so it's not going to be accessible from outside the university unless you VPN into the university. But you can still do serious damage inside of the university if you were so inclined, but don't. All right, so we got 13 more minutes for exam review. So let's see what we are supposed to know. Let's see, yeah. All right, so what did we go over? So we went over lots and lots and lots of JavaScript. Okay. So JavaScript. I don't know. I don't really know what to review about it. Hopefully, you guys are a little bit comfortable with it. It has all regular programming math stuff you might ever need. It has all regular comparison stuff you might ever need. There are functions that you can do. There are loops you can do. All right, there's a couple different types of loops. They all do exactly the same thing. Some require you to increment a variable that is keeping track of where you are in the loop. Others don't. So that's all on that one. That was extremely basic JavaScript. All right, then we got more complicated. Let's see. Got if statements, else statements, all regular logic-y type stuff. Switch statements, which is very similar to an if-else. And then exception handling, so the try-catch blocks allow you to have things that you think are risky in one place, and then if an error happens, you can handle it appropriately. Everything in JavaScript is an object, and there's lots of different ways to make objects. They all do the exact same thing. So JSON structure, like little squirrely bracket with name colon value is an object as well. I guess the generally the most confusing part about JavaScript is the event-based nature of it. So everything is an event. When you open a web page, that is an event. When you click on a web page, that is an event. When somebody right-clicks versus left-click versus long touch versus two-finger rotate, all of those are different types of events that you can set your JavaScript up to be notified of. And then when a user does that thing, then JavaScript will do whatever you want it to do at that point. What else? We have lots of different events. Tons and tons and tons. What's next? Leaflet. So Leaflet is one example of a JavaScript API for mapping. There are many of them. Leaflet is free, which is why people like it. There's most important part is to remember to include the Leaflet script. Otherwise, you can't use any of the Leaflet stuff. And then in all of the different APIs, you're going to have some div, which is a page division, within, within which your map is going to be placed. And you can have all of your JavaScript stuff for making the page do stuff and making the map do stuff either in the HTML file or in a separate file. It works both ways, doesn't matter. What else we got? So basically, you just find the example that does what you want it to do, and you make that work, and then you start modifying it for whatever is needed. There are markers, blah, blah, blah. There are pop-ups, and there are examples of how they all work. All right. So feel free to jump if you have any questions. No? Cool. You guys are Leaflet experts? Sweet. Then we did JSON, which is meow. So JSON is just a JavaScript object, right? So it can be as deep of levels as you like it to be. So it can be a full hierarchy that is handy when things are not nicely organized in rows and columns. So the example which we have in here, I'm pretty sure, is Fresh Prince of Bel-Air, right? So all of these first ones have a one-to-one mapping where Uncle Phil is one person, Will is one person, but when you get to Aunt Viv, a little different because she was played by two different actors. All right, so this is handy because representing this in a relational database would have taken at least 2 tables. You have to have one of characters, so you'd have one table just of character names, you would have one table of actors, and then you would have a join table between them, which said that this person played this character. So to do this with a regular relational table would have taken at least 3 tables. So with JavaScript object notation, it is much simpler. And this is how all data is transmitted for web pages. So it's good to know. GeoJSON is just a particular flavor of JSON that is a standard. Right? So standards are very important because people need to be able to produce data sets, and people need to be able to produce software that reads those data sets. So it's super helpful if the data makers and the software makers agree on what the data format should be. So GeoJSON allows you to just store geographic data in JavaScript objects, and it's what Arc Server puts out, so it's a good thing to know how to work with. Oops. All right, and then we have some REST calls. So REST is representational state transfer. So if you remember, everything on the internet is a uniform resource, which either has an indicator or a locator, so URL or a URI. And the REST way of using the internet is to not have to have the server or the client keep track of any state. So when you make a request for anything, it contains all the information necessary to get the request. So you may have worked with other systems where you have to do like next, next, next as you enter partial information little by little by little by little. So the server keeping track that you have finished step 1 and are now on step 2 and step 3 is ahead of you is state that the server is maintaining. So the purpose of REST is to not have the server maintain any of that state. So every request that you make to the web server has everything that the web server needs in order for it to be able to process your request. So how do REST polls work? So in the right-click inspect element network XHR section, inspect network XHR, those are all of the XML HTTP requests which are getting sent. So these are asynchronous requests. Remember, that means the whole web page doesn't freeze as it goes and gets some little piece of data. So it's asynchronous, not synchronous. But this is where events start becoming important, because this would be your JavaScript right here. You're saying go to this page on gisday.tamu.edu and get all the buildings. That request may take some amount of time to complete. So when you're done going and getting that request, then do this stuff. Right? So this is where event-based things become really important. When you start making requests to other websites or sources of data, and then just getting notified when the data has returned, so that way you can process it. So you would go and get some data, and then you would have a function that gets called when the data arrives. So in this particular one, it is marker callback. So a lot of the event handling methods in JavaScript are named callback because it's getting called when the data come back, I guess. I don't really know. So get some data, loop through it, add building to map with whatever fill color, weight, color, opacity. Cool. So REST will be, if you're calling ArcGIS servers to get data, you will be making REST calls. All right, we'll do that. ArcGIS JavaScript. ArcGIS JavaScript is a lot more complicated than other APIs, but at least you get access to everything that ArcMap can do. It's based on Dojo, which is annoying, and the biggest part is that all these little requires have to be in an order, and the way that these things in the function are listed have to be in the same order. So when you go and get yourself a sample of ArcGIS JavaScript and need to mess around with it, this is where you're going to break it, because you're going to add in one more widget and you're going to forget to put it in the second part, or you're going to put it in the wrong order in the second part, and things are going to break. So make maps. There are layers. There are pop-ups. You have to define the pop-up before you can use it in the creation of the layer. Another annoying part. All right. Feature layers and pop-ups. Right, and these are what's called templated, because they got a little squirrely bracket type thing in there, which is going to just substitute in the value from that row into there where you have that parameter name. What else we got going on here? There are a bunch of controls, like table of contents, zoom buttons, all that kind of stuff. There are widgets for everything. ArcGIS, I don't remember what advanced was. Geoprocessing, oh, printing, yeah. So advanced is using widgets, and widgets, you guys will likely not be making a lot of widgets, but you can make a lot of money if you do. Where are we at? Then 3D, instead of using feature layer, use scene layer, boom, works. So not too complicated. Operations dashboard, fancy little ArcGIS thing for making dashboards like that. Like this. All right, so as long as you have your pieces in ArcGIS Online, you just drag them, drop them where you want them to be, and then configure them how you want them to look, and you're good to go. Let's see. Story mapping, easy. D3 and high charts just allow you to visualize data. They both do almost the exact same thing. One just has more examples than the other, and one has qualifiers, the other doesn't. Any questions? Cool. You guys will do great, I'm sure. Everyone should get 100. If you don't, it means you just didn't feel like taking the test one more time. You'll have a VM, so you don't need to, if you don't want to, as long as you wanted to. Hello, do you want some data? Okay. Yeah, okay. I'll double check why. I'll go. Okay. Yeah, I'll send it to you right now. Right now. The server was out of state for the so that has now been solved. So, yeah. Yeah. Once you get what you get, you can tell okay.
Are you like doing a whole bunch of windows or just generating like well, you have a dark future of opioid addiction, whatever. Yeah, when I see you in the parking lot. Yeah, yeah.